So hi guys, today we're going to tackle chapter 4 entitled Network Access Summary. So going to um the tackle the summary of the chapter 4 Network Access. So um so um on sending device, it is a rule of data link layer to prefer data for transmission and control how the data accesses the physical media. So, however, the physical media by encoding how physical media controls how the data is transmitted onto the physical media by encoding the binary digits that represent data into signal. So um, two layers of the OSI um, models are so closely tied that according to the TCP and IP model, they are in essence 1 over. So those two layers are the data link layer and the physical layer. So I give you some of the so yeah. Now let's proceed to by the way, to support our communication, the OSI model divides the function of data networks into layers. So for the next one, so we have the the physical layer. The OSI physical layer provides the means to transport the bits that made up a data link layer. So frame across that made up a data link layer frame across the network media. So this layer accept a complete frame from a data link layer and encodes it as a series of signals that are transmitted onto the local media. So the OSI physical layer, it provides the means of to transport the bits and make of a data link layer frame across the network media. So the next one is physical layer media. So we have copper cable, fiber optic cable, and wireless. So we can see in here in the picture that we have the electrical signals, which is the copper cable. So the copper cable, the signals for the copper cable, the signals are pattern of electrical pulses. So you can see in this the outbound signal. So for the next one is the light falls or which is the fiber optic cable. So the for the fiber optic cable, the signals are pattern of light. So you can see it's like a pattern of light in the picture. So for the next one, we have wireless, which is the microwave signal. So you can see in the picture. So for the wireless, the signals are patterned of microwave transmission. So we can see in the picture. So for the next one, we have the physical layer hardware, media encoding, and signaling standard are defined and governed by the ISO, TIA, EIA, ITU, ANSI, IEEE, FCC, and ETSI. So the meaning of that, so for the ISO, which is the stands for International Organization for Standardizations, and for the TIA or EIA, it is the Telecommunication Industry Association and or Electronic Industry Association. And for the ITU, we have International Telecommunication Union. And for the ANSI, we have American National Standard Institute. And for the IEEE, which is I already tackled on chapter 3, It is the Institute of Electrical and Electronic Engineers, and for the FCC and the ETSI, it stands for National Telecommunication Regulatory Authorities. The FCC stand for Federal Communication Commission, and the ETSI is the European Telecommunication Standard Institute. So for the next one, we have the physical layer standard address three functional layer. So we have the physical components, encoding, and signaling. So for the physical components are the electronic hardware device, media, and the other connector that transmit and carry signals to represent the bits. So and for the encoding or line encoding is a method of converting a stream of data bits into a predefined code. So codes are grouping of bits used to provide a predictable pattern that can be recognized by both the sender and the receiver. And for the signaling, the physical layer must generate the electrical, optical, and wireless signal that represent the 1 and 0 on the media. So the method of representing the bits, it is called the signaling method. So, so we have here the bandwidth. So the bandwidth is the capacity of medium to carry data. So the digital bandwidth, it's measure the amount of data that can flow from one place to another in a given amount of time. So bandwidth typically measured in kilobits per second, megabits per second, or gigabits per second. So bandwidth sometimes thought of as the speed that bits travel. So however, this is not accurate. So we have so for the unit of bandwidth, so as I say, it is bits per second, kilobits per second, megabits per second, gigabits per second, and terabits per second. So so there are combination of factors that determines the physical bandwidth of a network. So we have the properties of physical media and the technologies chosen for signaling and detecting network signals. For the next one, we have the throughput. So um, the throughput is the measure of transfer of bits across the media over a given period of time. So many specific influence throughput. It is the amount of traffic, the type of traffic, the latency created by the number of network devices encountered between the source and destination. So this is the type of interface and ports available on the 1941 router. So as you can see, it has USB Type A connection, Gigabit Ethernet interface, plus Ethernet switch port, and others stuff. So for the next two, so as you can see in the picture, so for the next one we have copper media. So so copper media. So there are three main types of copper media used in networking. So it is the unshielded twisted pair or the UTP, shielded twisted pair or the STP, and the crucial. So we have here, you can see the in the picture the unshielded twisted pair. So and the shielded twisted pair and the crucial. So for the unshielded twisted pair cable or the UTP cabling, it is the most common networking media. So UTP cable that terminate with RJ45 connectors. It is used to interconnecting network hosts with intermediate network devices such as switches and the routers. So for the next one, we have the shielded twisted pair. So for the shielded twisted pair, so the shielded twisted pair or the TSP, it provide better noise protection than UTP cabling. So, however, compared to UDP cable, STP cable is significantly more expensive and difficult to install. Like UDP cable, STP uses an RJ45 connector. So, STP cable combines the techniques of shielding to counter EMI and the RFI, and wiring twisting to counter crosstalk. So, yeah, the shielded twisted cable provide more better noise protection than the UDP or the unshielded twisted fair cable. So, for the next one, we have the crucial cable. So for the crucial cable or the cush for short gets its name from the fact that um, there are two conductors that share the same axis. So the crucial cable, it consists of a copper conductor used to transmit the electronic signal and a layer of flexible plastic insulation surrounding a copper conductor. The insulting material is surrounded in a woven copper braid or metallic foil that acts or as the second wire in the circuit and as a shield of the inner conductor. So the last one is the entire cable is covered with a cable jacket to prevent minor physical damage. So this is the UTP connectors. So as you can see, it is the RJ45 UTP plugs. So for the next one, it is the type of the UTP cable. So the type of the UTP cable is the Ethernet. So Ethernet straight through and the Ethernet crossover and the rollover. So for the Ethernet straight through, it's the most common type of networking cable. It is commonly used to interconnect a host to a switch and the router to a switch to a router. So for the Ethernet crossover, a cable used to interconnect similar devices. For example, to connect a switch to a switch and a host to a host or a router to a router. So it is interconnect similar devices. So for the rollover, a Cisco proprietary cable used to connect a workstation to a router or switch console. So that's for the rollover. And for the next one, this is the fiber optic connector. So as you can see, this is the SC connectors. So we have here the ST connector. So the ST connector stands for straight tip connector. So it is one of the first connector type used. So the connector locks securely with a twist on and twist off bayonets type mechanism. So for the SC connector, which stands for subscriber connector, it's sometimes referred to as square connector or standard connector. It is widely adopted LAN or and WAN connector that uses push-pull mechanism to ensure the positive insertion. So for the next one, we have the LC connector, which is stand for the Lucent connector or simplex connector. So it's a smaller version of the fiber optic SC connector. It is sometimes called a little or local connector and is quickly growing in popularity due to its small size. So it's growing popularity due to small size. And for the last one, we have the duplex multi-mode LC connector. It is similar to LC connector, but using duplex connector. So for the next, so this is the common fiber patch cord. We have the um, SC multi-patch cord, SC multi-patch cord, LC common mode patch cord, STLC multi-mode patch cord, and SCST single mode patch cord. So for the next one, So this is the wireless LAN. So a wireless LAN requires the following network devices. So it requires the wireless access point, which is the AP, and wireless NIC adapters. So the wireless access point, or the AP, it concentrates the wireless signal from user to connectors to the existing copper-based network infrastructures such as the Ethernet. Then for the wireless NIC adapters, it provides wireless communication capability to each network host. For the physical and logical topologies, um, so the physical topology refers to physical connection and identifies how end devices and infrastructure devices such as routers, switches, and wireless access point are interconnected. So for the logical topology, refers to the way a network transfer frame from one node to the next. So we have the common physical one topologies, which is the point-to-point, hub and spoke, and mesh. So the point-to-point, this is the simplest topology that consists of permanent link between two endpoints. So for this reason, this very popular one topology. So for the hub and spoke, a one version of star topology, and which is a central site interconnects branch sites using point-to-point links. So in the mesh, this topology provides high availability but require that every end system be interconnected to every other system. So it is the frame fields. So the frame fields, we have the frame start, addressing, type, control, data, error detection, and frame stop. So the frame start and stop indicator plug is used to identify the beginning and the end limits of the frame. So, and for the addressing, it's indicate the source and destination nodes on the media. The type, it identify the layer 3 protocols in the data field. For the control, it identify the special flow control service such as quality of service. So let's go to the data. So the data contains the frame, payload, packet header, segment header, and the data. So for the error detection, so in the error detection, these frame fields are used for error detection and are included after the data from the trailer. So for the next one, so yeah, mean so that's the last one. And so thank you guys for watching, and I hope you learned in this chapter 4, and the I hope you learn a lot from what I say on this summary of the chapter 4. So thank you guys for watching.